Welcome to the third video in the Extreme Network series exploring network automation and workflows. While not mandatory, it is highly recommended to watch the first two workflow videos prior to continuing with this video, as many foundational concepts are discussed. Nonetheless, in this video, the Workflows component of ExtremeCloud IQ is used to build a security tool to enhance the command-level auditing feature of the Exoswitch operating system, with the goal of exposing the audience to workflows development that utilizes the Python programming language. So first of all, what is command-level auditing on an Exoswitch? Simply put, command-level auditing takes every CLI command issued by an administrator on the switch and reports, or logs, the exact command as an event. The audit event is then stored both within the switch's local logging facility and externally sent via the syslog protocol to ExtremeCloud IQ site engine, providing an off-site record of the issued command. This type of auditing is necessary within security-conscious networks and is an invaluable tool as a component of network compliance. However, as is the case with all event auditing systems, there are security concerns that event logging could be accidentally or maliciously disabled and render the compliance system ineffective. And this is where today's custom workflow will enhance security by constantly monitoring all EXOS switches to ensure command-level auditing is always enabled and exporting events to the site engine. To begin building this tool, the first step is to create a site engine custom alarm that monitors the EXOS audit events. First, let's add a new alarm and select the Custom Criteria Alarm option. The Custom Criteria Alarm type allows for specific log files to be continuously monitored and for the alarm to trigger if specific strings are matched against incoming events. The next step in the alarm creation process is to build out the trigger mechanism. Begin by setting the alarm name to Exoswitch Audit System Disabled, setting the severity field to critical, and selecting the enabled button. As the goal of this detection mechanism is to monitor the EXOS event feed, adding a log criteria of syslog is necessary as all external events are logged by the site engine to the syslog file. Note, the syslog file can be viewed manually via an SSH session to the site engine in examining the file /var/log/syslog. The next step in the configuration of the trigger mechanism is to add an information criteria trigger and input the search strings that match the EXOS commands that signify that the command level auditing has been disabled. The first command or string to add is disable CLI config-logging. This is the command that directly disables command level auditing. The second string to add is disable log target, as this command disables external logging to the site engine. It is important to note that before the switch actually disables logging, the disabled commands themselves are sent through the reporting path, allowing for a detection mechanism to be triggered. Once the two search strings have been added, select both of the disabled commands. Additionally, select the option Match Any Selected. This option ensures the alarm is triggered if either of the two disabled commands are detected. At this point, the trigger mechanism is complete. However, the remediation workflow has not yet been created, and because of that, no alarm action can be defined. Instead, the alarm can be saved as is, and after the remediation workflow has been created, the alarm action can be updated. For this particular workflow exercise, a partially populated workflow is imported to reduce the development time. If desired, this partially developed workflow can be downloaded from the Extreme Networks GitHub site and stored locally. To import the partial workflow, select the Under Development folder in the Workflows tree, and with the right-click menu, select the option to import. Using the File Finder, browse to the locally stored workflow bundle and import it into the Workflows tree. With the partial workflow loaded, let's start by reviewing the pre-populated items. As can be seen, there are 3 Python activities on the canvas, and they are currently unconnected. At a high level, the parse EXOS event activity processes the audit event that triggered the alarm and extracts key fields of identity data such as the attacker IP address and username. The Terminate Attacker CLI session activity attempts to terminate the active CLI session that disabled the auditing system on the particular EXOS switch. And finally, the Re-enable EXOS compliance monitoring activity issues the necessary commands to restore the auditing system back to an operational state. So let's break down each Python activity in detail, and while doing so, connect these activities into a logical and functioning tool. Beginning with the parse EXOS event, let's edit the underlying script and examine the details. As can be seen at the top of the script, there are 3 libraries that are imported. The RE, or regular expression, and the string libraries are standard Python libraries. However, the XMC library is special, as this is an Extreme Networks library that hosts numerous Python functions that are commonly used within workflows. The next small block of code is an internal function called reportMessage, and performs the simple task of collecting and storing informational messages produced by the Python script. This is an important function as all collected messages are later sent via email to the security administrator. It is also worth noting that there is an HTML line break element that is used to separate the individual messages within the Python variable. This is a handy trick that later provides separation of these messages when exported via an HTML formatted email. Next, the email message variable is initialized and is the Python variable that is used to store the informational messages that are collected locally within the script. Moving down to the next block of code, a variable is pre-configured with a regular expression to parse the EXOS audit event. As can be seen in the comment lines, the regular expression extracts the IP address and username of the attacker's CLI session, along with the specific command utilized to disable the auditing system. While regular expressions are not for everybody, they can be useful to parse out key fields from long strings of text. As a best practice, it is recommended to use one of the many web-based regular expression calculators to build out the expression before embedding it within a Python script. The next block of code makes use of the built-in emcvars function to extract 3 standard global workflow variables and localize them within the Python script for processing. These variables, alarm name, alarm source, and message, are all set by the workflow's environment when the workflow is executed by the custom alarm. Once these variables are localized, the Python script calls the previously detailed reportMessage function to add informational messages about these extracted details. The next block of code creates a local variable called success and sets the initial value to yes. This variable is used as a flag that is set to no if any error conditions are detected as the workflow progresses. This variable will be referenced at a later point in the workflow to determine the logical pathway that the workflow follows. Moving to the final action of this Python script, the previously built regular expression is applied to the raw audit event. And if there is a match, local Python variables are set for the attacker IP address, username, and triggered command, and then those details are added as additional informational messages via the reportMessage function. More importantly, though, these attacker variables are then stored as global workflow variables utilizing the built-in emcresults.put function. This function is critical as it allows a local Python variable to be stored as a global workflows variable. This ensures that other Python activities within the same workflow can access and localize the content of these global variables. To be clear though, only Python variables that need to be accessed by other activities within the same workflow need to be shared globally. Finally, 2 additional local Python variables are pushed out as global variables. Again, The contents of the email message variable is the store for all informational messages, and the success variable is simply a flag that is utilized when error conditions have been detected. As a best practice when storing global variables, utilize an uppercase character for each word within the variable name, while all local Python variables are strictly lowercase. This allows an easy-to-follow distinction and correlation between local Python and global workflow variables. After analyzing the parse EXOS event Python activity, there were 5 custom global workflow variables that were referenced. Each of these variables must be manually declared before they can be referenced within an activity. By moving to the Global Variables tab, these variables can easily be added. Simply select the Add button, set the first variable name, in this case the success variable, then set the scope field to workflow, and finally the variable type to string. Setting the scope to a value of workflow ensures that the variable can be referenced by any activity within the workflow. Additionally, setting the variable type to string ensures that any valid string content can be successfully stored within the variable. At this point, the other 4 custom workflow variables can now be added in the same fashion. These variables are attacker IP address, attacker username, attacker command, and email message. All 5 custom workflow variables have now been added. So let's begin the process of logically connecting the activities together. First, drag a connection from the start icon to the parse EXOS event icon. Next, the workflow needs a pathway decision to be made, and this involves the use of a workflow mechanism referred to as a gateway. This gateway allows for multiple possible pathways that the workflow can follow based upon a specific condition, such as the value of a global workflow variable. In this example, the parse EXOS event activity is logically connected to the terminate attacker activity through the gateway. By using the workflow's gateway, additional logic can be added. By selecting the outbound connection from the gateway and then choosing the Condition tab, the default condition is set to Always True. This setting ensures that by default, the workflow engine will always follow the pathway between the gateway and the next hop activity. However, in this example, a condition is set based on the value of a previously set workflow variable. Select the expression type of Evaluate Variables, pull down on the variable field and then select the custom workflow variable called Success, and then lastly, set the value field to Yes. These settings apply a condition to the connection so that it is only traversed if the condition is matched. In this example, if the success variable set by the parse EXOS event activity is set to Yes, the connection is a valid pathway. But what about the possible case if the success variable is set to a value of No? And this is where gateways can have multiple outbound connections. By dragging a mail activity onto the canvas and connecting the gateway to this activity, a second logical pathway is created. In similar fashion to the previous connection, the condition is set to a value of the success variable. However, in this case, the condition is matched when the value is set to No. In essence, if the parse EXOS event activity detects a failure condition, this pathway is traversed and an alert email is generated. To finish out this workflow pathway, select the mail activity and hit the Inputs tab. Select the email address or list that receives the alert, a valid email subject, and then add the global email message variable to the email body. Remember, email message is a global workflow variable that is populated by the Python activities with all of the informational messages. As a side note, variables can be utilized in either the email subject or body, but need to be surrounded by curly brackets and prefixed with a $ symbol. And then lastly, drag an end event icon from the palette onto the canvas and connect the mail activity to the end icon to ensure that the workflow path is properly terminated. Moving forward within the workflow, let's examine the Terminate Attacker CLI session activity. As mentioned earlier, the purpose of this activity is to terminate the attacker's CLI session into the EXOS switch. By examining the Python code within this activity, the underlying techniques to terminate the attacker's session can be fully understood. Let's begin by editing the Python script and performing a walkthrough of the code block by block. The first code block of interest is the section that localizes 5 of the custom global variables that were originally extracted in the parse exos event script. Again, any global workflow variable required for a Python activity can be localized as a Python variable by utilizing the emc vars function. The next block of code builds another regular expression that is utilized later in the script to locate the attacker's specific CLI session on the particular EXOS switch. Note how the attacker username and attacker IP address variables that were previously localized are now referenced within the regular expression. As the main body of the Python script is reached, an EXOS CLI command is executed against the particular switch. The CLI command is a simple show session that utilizes the include function to perform a simple string match against the session output for the known attacker IP address. The key concept with this line of code is that the built-up CLI command is actually issued against the particular switch by using the emc_CLI.send function that is part of the imported XMC library. The switch output from this command is then stored in the local results variable for later processing. And if the results variable is populated with session data, then the previously compiled regular expression is applied to the variable and the CLI session is extracted and saved to the attacker session ID variable. If at any point the attacker CLI session could not be found, the success variable is set to a value of no. However, if the session ID is successfully extracted, a second CLI command is issued to the EXOS switch to clear the previously extracted session. Again, the emc_CLI.send function is utilized to send this clear session command to the particular switch. In the last action of this script, the local email message and success variables are stored as global workflow variables with the emc_results.put function. With the walkthrough of the Terminate Attacker activity complete, it can now be logically connected to the workflow. Again, as a decision point is needed, a second gateway is dragged to the canvas and a connection is drawn from the Terminate Attacker activity to the gateway. Next, a mail activity is dragged to the canvas, properly labeled, and then a connection is drawn from the gateway to the mail activity, and then the condition is configured to evaluate the success variable, and if it is equal to a value of no, this pathway is taken. To complete this pathway, set the input variables exactly the same as the last mail activity, with the email list populated, the subject field set, and the email body set to the email message global variable. Lastly, for this pathway to be complete, drag an end event onto the canvas and then draw a connection from the mail activity to the end icon. With the failure pathway fully connected, the next step is to connect the successful pathway. Drag a connection from the second gateway to the Re-enable EXOS compliance monitoring activity, and then set the condition for the connection to evaluate the success variable again, but this time when the value is equal to yes. The last of the Python activities is called Re-enable EXOS compliance monitoring, and this script has the purpose of attempting to re-enable the compliance monitoring that was previously disabled by the attacker. In short, 3 different CLI commands are issued to this particular Exoswitch to ensure that CLI command monitoring functions are properly enabled. The first command ensures that CLI logging is enabled. The second makes sure that the CLI commands are shown in their fully expanded forms. And then the last command ensures that the external syslog destination is set. Again, all 3 of these commands are issued to the Exoswitch using the emc_cli.send function. And consistent with the other 2 Python activities, all informational and error messages are added to the email message variable and pushed out as a global workflow variable. The EXOS compliance workflow is now nearly complete. The final step is to drag another mail activity onto the canvas, set the activity name, draw a connection from the Re-enable EXOS activity to the mail activity, and then draw a connection from the mail activity to the end event icon. Lastly, select the Inputs tab for the mail activity and set the relevant fields exactly as the previous mail activities were set, with an email address or list, a subject line, and the email message global workflow variable in the email body. All that remains with this workflow is to adjust some final settings. Within the Menus tab, there is a category field that needs to be set to Security. This field will store the workflow under the Security branch and make it easy to find when associating it to an alarm. Second, in the Menus pull-down, select the Alarm option. The Alarm option allows for the workflow to be associated to a custom alarm as an action. And to complete this workflow, move to the Network OS tab and set the Network OS field to a value of ExtremeEXOS. This setting ensures that the workflow is only executed against EXOS-based switches. Basically, this option locks the workflow to one or more specific switch types. As all workflow development is complete, hit the Save button for the final time. Now that the workflow is complete, click on the Verify button to validate that the workflow is properly constructed. Once the workflow is valid, it can then be associated to the custom alarm created at the beginning of this exercise. Moving to the Alarms and Events screen, and then the Alarmed Configurations tab, the previously created custom alarm can now be updated. Edit the Exoswitch Audit System Disabled alarm, move to the Actions tab, select Add a Task Action, and then from the Security category, select the Exoswitch Audit System Disabled workflow. Once the alarm is saved, the testing process begins. To test the workflow, move to the Site Engine Network screen, select the Devices tab, and then right-click on an Exoswitch to open a terminal session. To trigger the EXOS audit alarm, launch the command disable CLI config-logging. After waiting a few seconds, note that the terminal session was forcibly disconnected by the triggered workflow. This result would have occurred no matter how the CLI session was initiated to the EXOS switch. So let's review the results of this security action as seen by the security administrator. First, let's open the email sent by the workflow that details the attack. Note that the email contains the attacker command, the forcible disconnect of the attacker session, and the commands implemented to re-enable the auditing system. Furthermore, once the security administrator has received the email alert, the Site Engine provides complete details of the compliance event. By moving to the Alarm screen, the triggered alarm, the impacted switch, and the triggered event are all readily visible. Additionally, the security administrator can examine the workflow's dashboard and locate the last execution of the Exoswitch audit system disabled workflow. Drilling into the workflow results displays the executed activities. The green activities were successfully executed and can be further examined by selecting the activity and then hitting the Show Output button. For example, in the Terminate Attacker CLI session, note the results show the attacker's CLI session forcibly cleared. So this concludes the third video in the Extreme Network series exploring network automation and workflows. Thank you for watching.